Have you ever wondered how computer programs are actually executed? How does software interact with the hardware to perform complex tasks? The answer lies in the realm of assembly language. In this lesson, we will delve deep into the world of assembly language, its importance, and how it functions as the foundation of modern computing. Let's go into the lesson. Let's begin by answering this question: what is assembly language? Assembly language is a low-level programming language that uses mnemonics to represent machine code instructions. Unlike high-level programming languages such as Java or Python, assembly language is specific to a particular computer architecture. It provides a direct interface between software and hardware, allowing programmers to write code that can interact with the underlying hardware components. The power of assembly language. Assembly language might seem archaic in today's world of high-level languages and sophisticated development tools. However, it is still widely used in many critical areas of computing. Here are a few reasons why assembly language remains relevant. 1. Efficiency and speed. Due to its close relationship with hardware, assembly language instructions are directly executed by the CPU without any translation or interpretation. This results in highly efficient and fast code execution. Assembly language programs can squeeze out every ounce of performance from the underlying hardware, making it ideal for resource-constrained systems or applications that require real-time responsiveness. 2. Low-level control. Assembly language provides programmers with fine-grained control over the hardware. Unlike high-level languages, which often abstract away low-level details, assembly language allows direct manipulation of registers, memory, and other hardware components. This level of control is invaluable in certain domains such as embedded systems, device drivers, and operating system development, where every bit of precision matters. 3. Portability and compatibility. Although assembly language is specific to a particular computer architecture, many instructions and concepts are shared across different processors. This means that once you learn assembly language for one architecture, it becomes easier to understand and write code for other architectures as well. Additionally, assembly language code can be easily integrated with high-level languages, enabling developers to harness the power of assembly language in their high-level applications. How assembly language works. At its core, assembly language operates on a simple principle: translating human-readable mnemonics into machine-readable instructions. Here's a step-by-step overview of how assembly language works. 1. Assembly process. The assembly process, also known as assembling, is performed by an assembler. In this process, the assembler takes the assembly code as input and converts it into machine code. Each assembly instruction is translated into its binary representation, which the computer can understand and execute. 2. Assembly directives. Assembly language also includes various directives, which provide additional instructions to the assembler. Directives specify aspects such as memory allocation, code organization, and symbol resolution. Directives play a crucial role in shaping the final output code. 3. Registers and memory. Assembly language instructions operate on registers and memory. Registers are small, high-speed memory locations within the CPU that can store and manipulate data. Memory, on the other hand, provides a larger but slower storage space. Assembly instructions explicitly specify the operands and memory addresses to carry out the desired computations.
In conclusion, assembly language may seem intimidating at first glance, but it is a fascinating and powerful tool that empowers programmers to interact directly with hardware. Its efficiency, low-level control, and compatibility make it an essential skill for anyone involved in systems programming, embedded systems, or computer architecture. So, if you're up for a challenge and want to explore the inner workings of computers, learning assembly language is an excellent place to start.